Hi all, welcome to part 5 of the video lecture on relational data model. So we are discussing relational model, its formal, informal definition, many aspects of it and the constraints, right? So the last parts of the video we discussed the relational model constraint, and particularly that entity integrity and referential integrity constraint is what we discussed in the fourth part of the video lecture. Now it's time for us to see is there any chance to violate this constraints that we already defined, say with the schema. So whenever you are doing some operation, there is chance, right? So the constraints may be violated. So let's see the operations of the relational model and their impact on the integrity constraint. Okay, so the operations are typically some retrieval operation and update operation we are making is we want to retrieve some information or you want to update. So when you do that update in the sense you may add a new value or you delete a value or you just modify or update the value. So these three basic operations you have to be careful, because this is when it may violate the integrity constraint. But if you are retrieving some information, there is no impact, right? Because you are just taking the data, it's not going to change any of the constraint, it's not going to have any integrity constraint violation. So you know what is insert and all. So insert is to insert one or more tuple, delete is to remove them, and update modify them, right? So whenever these operations are applied, the integrity constraints specified on the relational database schema should not be violated. So you have to ensure this. Okay, so that about it. Now let's see the operations one by one. So first let's see about the insertion operation. So let me take an example and explain to you. So it is something like the same usual example. Let's take the employee table. See, when you can have a constraint violation, say employee number, and you can make it as a primary key, and employee name and other details. So on the go I'll be adding. Okay, so like age, etc., and department number, of course, like that. So this is a foreign key and all, you know this, right? Okay, so now let me give you situations like suppose I am inserting employee number, say like AB. Okay, so you know it's a violation because employee number by default we mean for integers, right? If that is the case, otherwise it is fine. If you allow both numbers and characters as employee number, then it is okay, it may be allowed. But by default is assume that according to me, or let me take a different case. So employee number something I given, something like this. Employee name I am giving, and age I am giving something like say XY. So this is not allowed, right? Because age is expected to be a number, say between this one. And sometimes you may have further constraints also, like age. So what about the domain of this age field? Okay, so you can constrain this set of all x, where x belongs to say integer, right? Set of all integers I or z you can use, and x is having a minimum bound something like this and maximum value some 70, like that. If you are restricting like that and you are trying to insert any value outside this domain, that violates what? The domain integrity constraint, right? So that about it. So this is something invalid, right? So you are not supposed to take only value within the domain. So otherwise it will lead to domain integrity constraint violations. Similarly, so or let me write like xy itself, and I am saying that this is violates what? Violates domain constraint, right? Now another case, let me tell you. Suppose it's I have a tuple like this. So this is, I'm not going to allow this. So this is another employee details. Say here age, I'm giving a valid value like this, and other things also I'm giving. Now you know, next I'm trying to insert employee with the same one or two. So will it cause any issue? Okay, so if I'm giving, so other sorry, so this also there is a violation, so I don't want it. So all other fields are fine. The only thing is, so here you can, so this is also we are not going to allow, because key violation of key constraint, fine, key constraint, because key value should be unique, that is our requirement, and you are now trying to repeat the key value. This is something not allowed, right? So that is, so like that you can think of many violations here. And similarly, suppose here itself what I can so let me, so here it is I'm giving department number of 5, and let me show you the department relationship also. So department, if you are seeing, so here there is, so there is a reference, right? So from this DNO field to this DNum, there is a reference, and there are other fields of the department like a department name, etc. this manager, many things you can think of. I just want to highlight something like 5, there is details of the department, say D1, like that the details are there, and now 6 is there, now 7 is there, like that. Suppose I am trying to insert something, say, and other details are here, so something like 8. Now again there is violation of, so this also not allowed, right? Same thing, there are two issue. One thing, this primary key is repeating, it's not unique, and another thing is like the violation of what called the referential integrity constraint. Okay, so now one more constraint we study, that integrity constraint. So which says that the primary key should not be null. Suppose I try to insert the primary key as null, so this is going to violate entity integrity constraint, right? Violation of entity integrity constraint. So like that you can think of different integrity constraint violation whenever you are having this insertion into the database. So insertion can violate any of the 4 types of constraint we studied already. So for example, it can violate this domain constraint if the attribute value is given that does not appear in the corresponding domain, something we already seen like that age or something. Okay, so key constraint can be violated if you are entering the key value repeatedly. So if a key value in the new tuple T already exists in another tuple in the relation, that violates. And entity integrity constraint can be violated if you are trying to insert the primary key value to be null, like we saw lastly. And then the referential integrity constraint, of course, can be violated if the value of any of the foreign key field, like the DNO, in a tuple that does not exist in the reference relation, right? So like that. So if insertion violates, the default option is to reject it. Okay, so that is what we can do, and it is in this case it would be essentially if the DBMS software could provide a reason so why it is so that the user can rectify it. So he can clearly say that it's a violation of the referential integrity constraint on this particular attribute, like that. Try to give a valid reason so that the user can try with a valid attribute, I mean valid tuple. Fine, that about it. Now what about the delete operation? So that about insertion, it can violate any of the 4 integrity constraints we discussed so far. Now when it comes to deletion, you can see that it is going to affect only the referential integrity constraint. So this is important. Okay, so what I was trying to say is, here this is an invalid insertion and the only valid allowed insertion is this one. Right now what I am going to do is I am going to delete this particular entry. So now what you can do, so it is something like this. There is a reference from here to here, right? So this is the referential integrity constraint I am having. So this is my reference relation. So whenever I am deleting some entry from the referenced relation, so the problem is so deletion from referenced relation, not referred. Okay, fine, referenced or referred relation from referred relation. But there is no problem if you delete some information from here, provided it is not referred by some other table. Okay, so here there is a reference from here to here. So with respect to this reference, if you are deleting them, this will so there is a deletion from referred relation. Okay, so this leads to what? Referential integrity constraint violation. So that is the only possibility that you can think of. Violation. Okay, that you can think when it comes to deletion operation. Okay, so now what you can do, right? So once you are suppose you are forced to delete this particular entry, one thing you can do is you can reject this operation as a whole. You can tell to the user who is trying to delete it, you can reject this operation and you can say that it is going to violate referential integrity constraint. You are not allowed to delete it. So before deleting it, you please delete all the references to this 5, like that you can warn the user. Okay, so and you can reject the operation. That is one thing. Or without disturbing the user, what you can do, you can cascade the database software can do this cascading. Okay, so another thing is this cascading option. Cascading in the sense, whenever you are doing this deletion, you delete this also, then it is fine. Okay, so you are trying to delete, just the DBMS software will do this automatically for you. It will go for all the references to this and it will delete all those entries. So if it is done automatically, that is a cascade option. Okay, now the third thing that you can do is, when you doing this deletion, you just go here and this 5 is a reference, right? So wherever there is a reference, you put it as null, so that simply simply that particular department is not existing, so that these particular employees are not having any department, something like that. So it is up to the designer of the, I mean, who is implementing it, or from the mini world description you can decide what you want to do. Okay, so let me call it as set null. Okay, set null option. And another option that we are having is, you can set it to some default values. Sometimes there may be some default value for any attribute. It is something like suppose this department 7 is a default department, and we have the guarantee that we are never going to delete this particular department. It is a parent department or something. It will be there. If you have such a confidence, whenever you are deleting something like this, you put it to the default value, something like that. Okay, so I was just telling. So that is another option. So let me call it as set default. Okay, set default option. So like that you can think of different possibility when it comes to deletion. See, if you're trying to delete something like this, you have to take care of all those things. Okay, hope you get a feel about it. So the deletion can mainly violate the I mean, not mainly, it's going to violate only the referential integrity constraint. So this occurs if the tuples being detected deleted is referenced by the foreign key from another tuple, just like this 5 is being referred from as a foreign key from the DNF field of the, so this is our employee table, and this is our department. The same example I am taking everywhere. Okay, fine. So hope you are able to follow the examples. Okay, so in exam also, if they are asking, just take some small examples like that and try to illustrate the concept. So several options are available if a deletion operation causes a violation. The first thing is you can restrict, or you can simply reject it. Okay, such operations you are not going to allow, and you can warn the user, and you can tell them like you delete all the references, then you come and delete this particular row. So like that you can restrict it, but it is not a good choice. Okay, it depends. If that is the case, you can do like that. Now the second option is like a cascade operation, that is to attempt to cascade or propagate the deletion by deleting the tuple that references the tuple that is being deleted also. So whichever is deleting, whoever other tuples which are referring it, you are going to delete that also. Fine. Now a third option available is set null or set default operation option, that is to modify the referencing attribute values that cause the violation. Each such value is either set to null. So either you can, so just like I shown you lastly, you can set those references to be null, or it can set it to some default value tuple value. Okay, notice that if a referencing attribute that cause a violation is part of the primary key, it cannot be set to null. So the set null option and all, you have to be careful, because see here if you want, you can put it as null, no issue, because this department number field is not part of the primary key. But if it is part of the primary key, it may create another violation, like a primary key value should not be null. Hope you remember. So it may lead to that entity integrity constraint violation, something like this. Okay, we don't want it. Okay, so that you have to make sure. So an additional precaution. Okay, fine. So that you have to take care. So in general, when a referential integrity constraint is specified in data definition language, the DBMS will allow the database designer to specify which option applies in case of violation and of the constraint. So whichever option you want to apply when it comes to the violation of a constraint, that you can mention. Okay, whether you want to set null option, set default option, or cascade option, or that you can mention. Okay, so we will see when it comes to the usage of the comprehensive SQL language, and that time we will see how this can be done. So that about it. Okay, now the last thing is about the update or the modify operation. So just like delete or insert, we can think about this one. So update or the modified operation is used to change the values of one or more attributes of the tuple. Updating an attribute that is neither part of the primary key nor part of the foreign key usually causes no problem, because when you are updating a primary key, can you think of a problem? Because if you are updating it in such a way that you are the new primary value you are setting, you are changing the primary key value, right, for some tuple, and you are updating it to some value, if it is already available in the database, that leads to the primary key constraint violation, right? So now it's a duplicate, we don't want it. And similarly, if you are updating it to null value, that also will create issue, entity integrity constraint violation. So that is going to create issue. And also when you are updating the foreign key, similar to that delete operation, the same example you can think of. So here you are not going to delete, but instead you are changing the department number to say some 105. Then you have to cascade it, like here also you have to change it to 105, otherwise it is meaningless. When this guy is referring 5, it is not no longer exist because I changed the department number. I should not say like that. So whenever I am making any update like that, I have to cascade it, or the set null or set default, whatever option you want, you can give, that is fine. Okay, or you have to at least reject the operation. So just like a delete operation, you can think of a modification to the foreign key attribute. Instead of deletion, we are changing it. So you have to ensure that all the references are also, either changed or set null or set default, whatever you want. Just like delete, you have to propagate that change somehow. Okay, but when it comes to primary key, if you are deleting it, you have to ensure you are not going to update it to a value which is already existing. Duplicate should not be created, and also it should not be null. So those things you have to take it. So modifying the primary key value is similar to deleting one tuple and inserting another tuple, because you are changing, right, it's somewhat like a new tuple is being inserted, because primary key is the one that is making this tuple unique, right? So because it is identifying the tuple, right? Hence the issue discussed in the insert and delete both will come to play, and you know how to rectify it. You have to take care. Reject or reject is the best option. So if a foreign key attribute is modified, the DBMS must make sure that the new value refers to an existing tuple in a referenced relation. So here the problem will occur at both sides. Some updation here you have to propagate here, and also when another thing is this, here you may update like say to some 10, but such a value is not here. That also will create problem. Okay, so that everything you have to take here. So similar options exist to deal with the referential integrity violation caused by update, and you can think of all these cases. Okay, in fact, when referential integrity constraint is specified in DDL, again just like delete, on delete, you can say on delete cascade, like that we will write like so during deletion, what is the option for keeping that referential integrity constraint correct? Like you can set like on delete cascade option, or on delete set null option. Similar to that, on delete update option, or on on update cascade option, or on update set null option, like that you can set while you are defining the schema. So that along with the definition of the schema, we are defining all the constraints, right? So that time you have to mention what is the possible thing that you can do when if there is a constraint violation. Okay, the default thing is rejecting the operation unless otherwise stated. Yeah, that about it, the constraint and its violation. Hope you get an overview about it. Yeah, thank you, thanks for watching.